In this video, we're going to be doing some elementary algebraic operations involving matrices. So we're going to start with a couple of 2 by 2 matrices. We have the matrix A, which is 4, -1, 2, 3, and the matrix B, which is 0, -3, 2, 5. First thing I'd like to do is known as a linear combination of these two matrices. I'd like to do 2 times A plus 3 times B. So for 2 times A plus 3 times B, we'll be taking 2 times the 2 by 2 matrix, 4, -1, 2, 3, plus 3 times the matrix, 0, -3, 2, 5. Now, matrix operations will obey the order of operations. So in the event that you have a multiplication as well as an addition taking place, you'll need to worry about doing the multiplications first. Now, the multiplication by a scalar like this will distribute through to all 4 of the terms in each of the matrices. Then we'll add them together component-wise. Distributing the 2 to all 4 of the entries in the first one, that'll be 2 times 4, 2 times -1, 2 times 2, and 2 times 3. We'll do the same thing for the second matrix, 3 times 0, 3 times -3, 3 times 2, and 3 times 5. Then corresponding entries will get added together. For the 1, 1 entry, we'll have 8 plus 0 for 8. For the 1, 2 entry, -2 plus -9, that'll be -11. For the 2, 1 entry, 4 plus 6, that'll be 10. And for the 2, 2 entry, that'll be 6 plus 15, and we will get 21. So final answer for this one, 8, -11, 10, 21. Next up, we're going to find the matrix product, A times B. So we will be performing matrix multiplication. This is 4, -1, 2, 3, multiplied by 0, -3, 2, 5. Now, for the matrix multiplication, we're going to be going across rows of A and down columns of B and multiplying corresponding entries together. So, right next to this matrix product, I will be putting what these corresponding entries will be. For the 1, 1 entry, we go across the first row, down the first column, do 4 times 0 plus -1 times 2. So 4 times 0 plus -1 times 2. For the 1, 2 entry, we go across the first row, down the second column, do 4 times -3 and -1 times 5. 4 times -3 and -1 times 5. For the 2, 1 entry, we'll go across the second row, down the first column. We'll get 2 times 0 and 3 times 2. So 2 times 0, 3 times 2. And finally, for the 2, 2 entry, we'll go across the second row and down the second column. 2 times -3 and 3 times 5. 2 times -3 plus 3 times 5. Then we'll perform all of that necessary arithmetic inside, and we'll see what we get. That is 0 plus -2. Here we have -12 minus 5. 0 plus 6. And -6 plus 15. So final answer for this one is going to be -2, -17, 6, 9. Now beyond this, we're also going to be calculating a couple more. The next one is going to be B times A. So for B times A, we'll set this one up in a similar fashion. Remind ourselves, matrix B is 0, -3, 2, 5, 0, -3, 2, 5, and once again, matrix A is going to be equal to 4, -1, 2, 3. 4, -1, 2, 3. Good. So like we did in the previous example, for the first matrix we're going across rows, and for the second matrix we're going down columns. Select the appropriate row from the first matrix and column of the second matrix. to get the corresponding entries. So for the 1, 1 entry of the product, we'll be going across the first row and down the first column. That'll be 0 times 4 and negative 3 times 2. 0 times 4 plus negative 3 times 2. For the 1, 2 entry across the first row, down the first column, multiplying the corresponding entries together. 0 times negative 1 and negative 3 times 3. 0 times negative 1 and negative 3 times positive 3. For the 2, 1 entry, we'll go across the second row, down the first column. 2 times 4 and 5 times 2. 2 times 4 and 5 times 2. Then for the 2, 2 entry, we'll be going across the second row and down the second column. 2 times negative 1 plus 5 times 3. Once again, we have a lot of arithmetic to do, but once we do, we'll be done. So that's 0 plus negative 6, 0 plus negative 9, 8 plus 10, and negative 2 plus 15. So final answer for this one will be negative 6, negative 9, 18, and 13. Something very important that I'd like to call attention to when we multiplied matrix B times matrix A, we did not get the same result as matrix A times matrix B. We can say in general, AB is not equal to BA. Matrix multiplication is referred to as a non-commutative operation. Matrix multiplication is non-commutative. We cannot reverse the order and have things be okay. Now that said, one more that I'd like to have us try out is going to be A transpose times B. Now, as a little reminder for us, matrix A, which I'm recopying from just up above, is 4, negative 1, 2, 3. A transpose is what we get by turning the rows of A into columns of A transpose, and vice versa, columns of A into rows of A transpose. So the first column of A is 4, 2. The first row of A transpose will be 4, 2. The second column of A is negative 1, 3. The second row of A transpose will be negative 1, 3. You can also think of A transpose as saying, let's perform a reflection about the main diagonal of the matrix. So the 2 and the negative 1 change positions and everything on the main diagonal, that'll stay the same. So A transpose times B will be equal to A transpose, 4, 2, negative 1, 3, multiplied by the matrix B, which was 0, negative 3, 2, 5. I've only requested a transpose of A. If I wanted a transpose of B as well, there would be an additional superscript T after the B. Then, same as the last two matrix multiplications we've done, we go across the first row of the first matrix and down, across the rows of the first matrix and down the columns of the second matrix. So for the 1, 1 entry, that'll be 4 times 0 plus 2 times 2. 4 times 0 plus 2 times 2. For the 1, 2 entry, that'll be first row of A transpose, second column of B. 4 times negative 3 and 2 times 5. So 4 times negative 3 and 2 times 5. Nice. For the 2, 1 entry, that'll be the second row of A transpose on the first column of B. Negative 1 times 0, 3 times 2. Negative 1 times 0, 3 times 2. And finally, for the 2, 2 entry, that'll be the second row of A transpose and the second column of B. Negative 1 times negative 3, and 3 times 5. Once more, lots and lots of arithmetic for us to do. We have 0 plus 4, negative 12 plus 10, 0 plus 6, positive 3 and positive 15. You'll notice that this result is also different from all the other results that we've gotten. Well, it should be. It's not equal to any of the other things.